Good morning, ladies and gentlemen, and welcome. If you could please take a seat so that we can get started. A few recommendations before we do. I'm sure that there's going to be a number of people arriving late, so I hope they'll make their way quietly. But in terms of being quiet, I do kindly ask you to turn your mobile phones off or have them on silent throughout. The good news is that there will be a good coffee break after the initial three sessions. So you'll have ample time to discuss amongst each other. The format of this roundtable conference day or half day is a combination of presentations in explaining, introducing technologies, challenges, adoption, engagement for sustainability objectives, obviously in links with the Energy Boat Challenge. But there'll be also a lot of time for the audience to ask questions. So don't hesitate to ask questions to the panelists after they've done their presentations, and I'll be asking questions as well. So it's meant to be really interactive. All that said, I'm going to leave Charlotte Mille, who's the project manager for the entire program of the Energy Boat Challenge, to welcome you. And then I will invite our first speakers to come to the stage. Thank you for being here, and I hope you have an enjoyable, interesting session today. Thank you.
Thank you, Laurent. Well, I would just like to say just a few words because we're going to be running a bit late, but we were waiting for some of the guests to arrive. Thank you very much all for being here. Thanks to our speakers who made their way to the Yacht Club of Monaco to share their view on sustainability transition, challenges, engagement and adoption today. We'd like to thank also the attendees, because for us it's very important to share what is the vision of yachting, what is the vision of innovation and research and development and sustainability. And we really invite you to speak up and ask your questions during the panel. I also would like to all invite you after the conference to go down to the quay and go and check out what is happening quayside. Because quayside you have over 30 teams with prototypes and commercial available boat. And they're, I think, quite all interesting to discover. You have teams from all over the world. They came from Indonesia, from the UAE, from the US, from Europe, from Italy. And they're all very passionate about their work. And I think they would be very, very thankful that you as industry players go and discover their work. Most of them have developed prototypes with electric propulsion. Some of them are also working hard on the life cycle assessment of their boat and are having a reflection on how they're building their boat. So please ask them questions. Some of the teams, 7 of them have a hybridization with hydrogen solution. So really, those are the future minds that you may want to have in your companies. And they're also maybe interested to join you in the future. So we are all about making connection here, making connection with the students. There are about 420 downstairs. But we also have the commercial available boats, which I think are quite fun to go and discover. So thank you again for being here, and I wish you a good conference and a good stay with us.
Thank you, Charlotte. So without further ado, I would like to call on stage Mr. Luca Santella from Blue Game, who's developing the chase boat for the America's Cup for American Magic. And I would like to ask also Umberto De Luca, who's the project manager for Luna Rossa Prada Challenge for the America's Cup, to join us on stage. They'll be presenting and introducing the work they've done on developing these boats, which are basically probably what you can do with the utmost technology on board small size tenders. So it's like a compact demonstration of everything that can go onto these boats, and we'll discuss these complexities afterwards. Again, feel free to ask them questions. So I'm asking first Luca to introduce himself and then to explain and show us the boat he's worked on. And afterwards, we'll do the same with Umberto. Thank you, gentlemen. You have to turn it on.
Eccoci. Good morning, everybody. I am Luca Santella. I am the founder of Blue Game, and actually I'm the head of strategy of this brand. And also I follow the style of both Blue Game and San Lorenzo. So I'm doing a lot of work in the company, but when we had the chance to start this project, I had no doubt our brand should be involved in this fantastic experience. Building a team, risking, being guided more by emotions, being at the cutting edge. They are accomplished professionals, driven by an impressive passion. Yes, a boat, but she flies. Concept boat, sailing at 50 knots, flying in silence, an incredible achievement. It will be the most technologically advanced boat sailing in the world. BGHSV, Hydrogen Support Vessel. It will be the first boat, not a sailing yacht, that will sail totally emission-free. Almost 200 miles of range. Foil, hydrogen-powered fuel cell, electric motor, batteries, composite box, hydrogen powertrain, software for controlling the boat flight. HSV is tied to how much we believe in the future of the multi-hull, to the philosophies of both San Lorenzo and Blue Game. It is truly a revolution for the world of pleasure yachting. This boat will sail with the New York Yacht Club American Magic during the next America's Cup.
Thank you, Luca, for this very nice video. I think they do deserve a round of applause for that magnificent project. So before we shifted to Luna Rossa, just a few words about your boat. Can you give us a bit more explanations, technical explanations about the complexities and the challenges you faced? When we look at this picture, it seems quite simple.
Thank you. Yes, it does look simple, but there is a lot more underneath the hull and behind all the system we show in this slide. Here you just see the hydrogen tanks, batteries, the fuel cell in the front area, the e-motor, which is hidden just above the struts. But below that kind of systems, we have 9 inverters. And all these inverters are water-cooled, which means there are intercoolers, there is piping, plus all the electrical piping. So luckily, there is not the second slide where all this stuff is shown. Otherwise, it would take the morning to share it and explain it to you.
Thank you. I'm sure you'll have plenty of questions from the panelists. And I have some questions for the two of you as well. Now I leave Umberto to give us a few words about their project, which, as you can guess, given the rules defined by the America's Cup team, means that their boat is basically more or less based on the same specifications, but he will tell us a bit more about it. It should work. Here we go.
Good morning, everyone. My name is Umberto De Luca, and I'm the project manager coordinating the design and the construction of our HSV for Luna Rossa Prada Pirelli team. I'm going to start off outlining a bit the rules where basically this project is coming from. As part of the AC37 America's Cup protocol, each team is required by rule to employ a minimum of one HSV, which is going to be the only vessel employed on the race course. It's going to be the only vessel allowed to enter the race course. So it's key for each team to have a working and reliable vessel on the venue. We have mainly performance requirements given from the AC organization. We have to have a minimum range speed of 75 nautical miles on hydrogen and batteries power alone. And then we have some speed requirements, which are that we need to be fully foiling at speed of 24 knots and above. And as well, we have to hit a top speed of at least 50 knots. They also give some requirements in terms of installed power, which is 160 kilowatts of fuel cell power, and a minimum length of 10 meters. So this is actually the whole rule there is on HSV. So it's a pretty, it's a sort of a box rule, but it's pretty open. So there is a lot of space for for development and coming up with your own solutions.
Before we get to the technical explanation that you'll give us, I have a question for the two of you, actually. Since there's no one from America's Cup in the room, do you know why? I mean, is it the first time, in a way, that in the America's Cup there's been such a strong requirement or defined requirement for the support vessel? And part of that question is, why did they actually impose on everyone to work on such developments? Because usually you think about technology for the sailing racing boat, but not so much for the tenders. So do you have any words to share with us on that?
Yeah, I think it goes, I mean, I think nowadays, the effort is to try and be, let's say, as green as possible in every aspect. That's why they're implementing these new rules also on the support fleet. I mean, you wouldn't think, but like to follow these boats at 50 knots, you burn quite a lot of fuel. And so, and you have to have multiple support boats normally during a normal sailing session. So it makes sense to, let's say, start this transition towards having, say, greener support vessels. They're quite, as Luca was saying, they're quite complex vessels. So I guess it will take a little bit of time to get to the same level of reliability, at the same level of as the current support vessels are, but hopefully we will get there.
Yeah, so the requirement is first based on sustainability. That's the key objective for them.
Yes, I would think so, yeah.
Luca?
Yes, I think beside what just said, it's a general trend of our market of the pleasure boating, looking for being more and more sustainable. So this is just the beginning, and the America's Cup is a fantastic scenario where we can be. So I think it was very smart from the organization to use this occasion, fantastic occasion, to show the world that also in the power boating we can start, and we are actually doing a fantastic work. For example, San Lorenzo will be present next year beside our tender with 50 meters.
Yeah, we'll talk about that tomorrow, in fact. So,
Okay. So it's really an important movement. It's not just a very simple example of research.
okay, thank you. Umberto, we shift to the technical explanation.
Yeah. Sure. I'm going to disappoint a little bit with the fact that we're not going to show any pictures of the boat until it's launched, but I thought it would be interesting to go through what are the main design challenges and the design process. One of the options you have for designing this type of craft, all the steps to follow along the road. So basically the main, at least from our point of view, the main challenge is the top speed. I mean, when you're going at 50 knots, you have you start to have all sorts of problems related to cavitation. So your appendages have to be designed for working across a very different range of speeds, because you have to have a takeoff for this weight of vessels at a relatively low speed, and then they have to be efficient at high speeds. So cavitation prevention is quite a big driver in the design of the appendages. As well, your boat needs to be light, because you don't want to overload your main foils for, say, decreasing, again, the risk of cavitation. Another key aspect is that because it's a really innovative vessel, very rarely there is an off-the-shelf solution. So you have to work in a team to come up with your own solutions. You have to work with your suppliers to develop a product that fits in your boat, that is light enough to work well with the rest of your systems. And again, if you are, say, working with different suppliers, you have to make sure like the different parts communicate with each other properly to ensure reliability of the systems. So starting from the protocol requirements, there are some decisions you have to take early on. So you have to come up with a hull shape, as you normally do when designing a boat. One of the key aspects of this project was to have enough, let's say, internal volume to host all these large pieces of equipment, which could be the tanks, the batteries, and the fuel cell. As well, you have to look into being efficient at going 50 knots, so aerodynamic drag becomes a bit of a driver for your external surfaces. And then after you have designed your hull and selected your hardware and make sure it fits, you start going into the scantlings and the composite design. You do a FEA of your platform. You make sure you have a big enough safety factor to have a safe and long-lasting vessel. And along this whole process, you keep track of your weights. You make sure you are within the targets. You make sure your center of gravity is roughly where you intend it to be, to have a good split of weight between your main foil and the rudder. And as well, along the way, as I was saying before, you design your appendages. It's not just the shape, but because you have to have actuators changing the flap angle or the rake angle of the rudder, there is quite a lot of complexity going into integrating these systems into the appendages. As you saw from the video before, but also if you looked at the videos from Team New Zealand, from Chase Zero, you see they have quite big bulbs, which are integrating the water cooling suction inlet. They are integrating the foil flap systems as well as the drive unit. So there is a lot of moving parts going into these bulbs, and it's quite complex to fit everything in such a small volume. And And when you're done with your, so if you can go back one last point, is along the way you also have to keep to simulate the controls of this boat and make sure like the appendages setup you have is actually feasible for being able to control the boat in a safe manner. The peculiarity of these boats is that they have to heel to turn. You cannot do a zero heel turn because you have too much lateral force. So you have to make sure your control systems behave the way they are supposed to be to match the physics of this type of vessel.
So would you say that this is the most complex part in terms of like shifting from simulation to the actual execution and making sure it fits? And I would ask the same question to Luca in terms of the complexity of the engineering. What was the most challenging? What has been so far the most challenging, or where you see the most complex part of it?
I start. Oh, sorry. I think. I mean, for us being used to building race boats, I would say maybe the composite part is something we are more accustomed to. But the rest, I mean, all the systems related to hydrogen distribution and power generation is not something we normally do on our race boats. So it's something we had to learn about and draw know-how from other people in order to make sure everything works. As well, the appendages design is quite a tricky and complex part.
Thank you, Luca.
Even if we are building normally power boats, this boat is so special, so unique, that I can say that the part regarding power management, but overall the transmission system is the most complex part, because the two struts have hydrodynamic constraints, in the sense that they are very critical for high speed, so they have to be very thin. And in the meantime, they have to house water intake, shaft for transmitting the power to the propeller, plus shaft to move the flaps. So for us, I think that was it's the most innovative and complex part to design and to build.
Okay, thank you. A quick question on the fact that it's a hydrogen-powered boat, foiling, flying boat. We've seen, I mean, you've seen those who attended the E-Rally yesterday. You see electric boats that are foiling. Then you know that there are some hydrogen-powered boats that are in build as well, not necessarily foiling. So what do you think of that combination of having to deal with a flying boat that also runs on hydrogen and batteries? I mean, what do you see as benefits, and do you see as that's something developing that could become, I wouldn't say mainstream, but integrating into pleasure craft? We're talking about new technology, so obviously batteries, hydrogen, foiling, all that put together. Your vessels are quite a prime example of that technology. So how do you see that, given the theme of today being adoption, being able to be used by other shipyards maybe, and develop such boats for pleasure craft? What's your thoughts on that?
Well, I really believe a lot in the foiling. So I do believe maybe it won't be mainstream, but it will be a very important part of our area of work, of our market. Just to let you know that we are just beginning a new project, which is we will be part of a Blue Game production, and it's going to be a multi-hull with foil, and it's going to be in the market in next year. So we're really working hard on it, and this is just to let you know how much we believe in this direction. Obviously, it won't have any electric or hydrogen at the moment, so it will be a normal IPS-powered, Volvo Penta-powered boat. but it's at the beginning of research of looking for a better solution in terms of consumption, in terms of comfort, because the boat will be much more comfortable at average speed. So we do believe in that, and we are working on this.
Umberto, do you see the developments, as you said, I mean, that's not initially your background because you're developing sailing racing boats, but do you see the work you're doing turning into being applicable to other type of craft, or for you it's mostly R&D at the moment?
No, yeah, I see it. I mean, the America's Cup has always been to the sailing market as the Formula One is for the automotive industry. So sometimes you have solutions that can be applied to mainstream crafts. So I think it's good that we are developing a foiling boat because in a way it's more extreme, and you have to push to be to have lighter components, more compact components, more efficient systems. So I think for the industry as well, it's good that we have this effort that can be then replicated onto other crafts. And as Luca was saying, the foiling is probably going to be the future on a very wide variety of vessels, especially because of the comfort. I'm sure most of our guys are looking forward to having this boat, because when you have to go fast in a sea state, foiling is much more people friendly than a normal displacement boat that's pitching and rolling all the time.
And sustainable too.
Sorry?
And sustainable too.
And sustainable too, yeah.
Thank you, gentlemen. Before we get then part of the further development of racing boats with Rodi Basso from E1 and Boris Herman, skipper of Team Malizia, to join us, I'm sure that you probably have some questions for our two gentlemen here in the audience.
What are the main scenarios or applications for the kind of design you have at the moment when you're talking about commercialization?
I think this is for me. There is, as I was telling you, we are already working on a 45-foot cat, pleasure catamaran, and we are taking a lot of experience we did so far in this project with the composite, with design of foiling, with the team we put up together to face this challenging project. So there is already at this moment a direct link between this project and production. But we have already other projects in online, in our timeline, which will introduce also electric power and hydrogen power. So this project is incredible because it's like throwing a rock and everything is going to follow. So I'm really confident it will be a fantastic example for all our market.
Thank you. Any other question? All right. You'll be able to obviously talk with these gentlemen. So when we have coffee break or during lunch, if you want to have more technical exchanges with them. So I would like to call Rodi Basso, who is the CEO of E1, to join us so that we can also talk about power boating racing. You've seen with the challenge, there's a number of boats here. Is not just, racing on the water is not just about sailing. There's also power boating with a lot of engagement into sustainability. So if Rodi can join us on stage, please welcome him to the stage. And we were meant to have Boris Herman joining us, but it seems that he's not available, not around, maybe still on his boat, which you can actually take the opportunity to visit after the conference down on the quay. So the reason for bringing Rodi and supposedly Boris is to talk about racing boats for the future. We know what is being done at the moment when you look at the technological developments of America's Cup boats. We've seen what now you do with tenders as well, chase boats. But the idea here is to see with them what do they foresee in terms of future racing. As Umberto was saying, there's a lot of comparison with Formula One, with the automotive world. We'll get back to that later in the day. And this is typically one of the key questions, is not just how do you compare or how do you bring the two worlds together, automotive and obviously racing, sailing, but also with power boating. So I'll leave Rodi to start doing the initial introduction of himself and explain where they stand with the E1.
Very much. I guess this is switched off.
No, it's on. It's fine. Okay.
I'll try again. Good morning, and thank you very much for the invitation to this panel. I have to say the introduction is very relevant. I just introduced myself. I'm Rodi Basso, co-founder and CEO of the E1 series. I founded this company together with Alejandro Agag, who's the father of Formula E and Extreme E, and soon there will be a fourth championship coming and to be ready to be announced. So he's, of course, an entrepreneur in motorsport and with a great reputation in terms of execution of futuristic projects. So my background is actually coming from Formula One. I'm an aerospace engineer, but I've been working in Formula One teams. I was race engineer for Rubens Barrichello in Ferrari, and then I went to Red Bull with David Coulthard, and then I moved more into technology business. So I was in Magneti Marelli, developing solutions in terms of high voltage, low voltage, and data intelligence for racing. And then McLaren Applied Technologies, which is a very strong and interesting company that is not only developing solution for racing, but also trying to address solution learned in the racing environment on the racetrack and then exported and cross-fertilized in other fields like trains, healthcare, and so forth. In McLaren, I was managing director, and actually when I was there, I was being very involved with Formula E because we developed the battery for Generation 2, which allowed the championship not to swap cars during the race. And this was a massive project. That's where I met Alejandro. And I come from a sea place. I'm from Italy. I'm from Napoli. Very passionate about sailing, I have to say. More than powerboarding. I never followed powerboarding again. I'm a new face in this environment. But I strongly believe in the combination of sport and technology. And I also strongly believe in innovation by cross-fertilization. That's what I learned also in my McLaren days. So given where automotive, supercars and hypercar and motorsport is now compared to where the marine industry has been in the last 20 years, I thought that there was a gap and an opportunity to build a new sporting platform, trying to import from automotive and racing all the technology in terms of high voltage and low voltage, and then speed up the process of the electrification in the marine industry. So the first step has been to get this license from UIM. The championship is called UIM E1 World Championship. And through this championship, we are working on launching the championship in February and delivering this exciting boat that actually is around these days, and it will be back in Monaco in a year's time for the first race in Monaco of the championship.
So you see the future of e-racing or motorboating racing basically being like 100% sustainable, or I mean, is that the objective ultimately?
So sustainable is becoming a bit of a bad word in these days, because every time you hear about sustainability, it looks like we're talking about a very vague topic. And so I like to, first of all, the answer is yes, because the planet is clearly telling us that there is an issue. Okay, I go sailing since many years. I'm not going to tell how many years, but the rapid change in weather condition that I see during summertime in these days is not the same that I was experiencing years and years ago. So there is an issue. I mean, reading the news, and not only, I mean, this is not only coming from a general perception of me and Alejandro, but we also have a scientist, Carlos Duarte, who is one of the most important, if not the most important marine biologist of the world, and is clearly coming with evidence, scientific data and evidence that the issue is there. So we all want our kids to keep enjoying the water as we have done so far, and so we need to do something. I'm not saying that we have the solution, but what I'm saying is we are keen to kick off a project, and then from that moment, train, test, measure, and improve. And this is the cycle that we need to introduce in order to, again, continue enjoying the coastal areas of this world.
So basically, you're trying to apply, in fact, what's been done in Formula One, Formula E, to the yachting world with the E1 series, and hopefully then get that into developing into solutions applicable daily. I have a question, in fact, for the sailing teams here, because when we talk about sustainability and new technologies, it's true that most often it's about propulsion, drivetrain, and how to, avoid the use of fossil fuel. But we also know that a lot, and in fact it was one of the reasons for Boris to be here, a lot of the aspects linked to the building of sailing racing boats has to do also with obviously the type of materials that are used. So it's not just about power. When you're sailing, you think that you don't have an impact. But the reality is that the building of a boat does have an impact on the environment as well, not just when it's being used. So on the Luna Rossa product challenge, what's your approach to that? I mean, in terms of whether the constraints from the America's Cup or the initiatives that are made to help develop more sustainable boats, basically.
So at the rule level, we are obliged to use recycled material or a percentage of recycled material into the production of the molds. And you have to provide certificate to the measurers that you are, in fact, using recycled material to build your molds. So this is already a good start because they are quite large surfaces. Then in terms of the actual materials used, the America's Cup, as you know, is a very, very light and performing construction type of construction. So you normally tend to use materials that have been validated over time and then are high performance. And at this level, we, at the moment, there has been, let's say, a little bit of progress made, but they are not, let's say, still where they could be. In my view, another big, let's say, because always when you talk about sustainable construction, you talk about the materials that are ending up on the boat. But if you follow the construction process, there are a lot of materials that actually are used only once and then discarded. For example, all the consumables that go into your construction, like the bag, the breathers, all the tape you use, all the sealant. So I think which many times are few times the surface of the part you are building. So it's let's say relevant quantity. So we are trying to use recycled material on some of these consumables. But again, I think the strive of the industry should also be to try and go greener on these products as well. I think it will make quite a big difference.
Okay, thank you. Luca, I have a question for you as a shipyard involved in obviously developing products and projects for the America's Cup here. You can see in the, we're comparing with Formula One, Formula E, how the engineering side in the automotive world and the brands, the car manufacturers are getting involved directly, I would say, having their own teams, Formula E, Formula One, whatever. Why is it something, or is it something that you see happening in the yachting industry? I mean, we've got a representative, a number of shipyards here. Is that something where that type of process from R&D turning into racing, then turning into developing products for the market, is something that will happen, is happening, would happen? I'm taking the example of the challenge here. You look at the Energy Boat Challenge, it's mostly universities, and now you can see that some shipyards are getting involved into applying and taking part into the challenge to work on future solutions. So what's your thoughts on that?
It might be, and probably it will. On our side, we are very, very careful about this development. And we are here helping University of Genova at San Lorenzo. And we are looking carefully to the rest of the competition, so I can tell you more.
Okay, thank you. On the E1 series, again, propulsion, I mean, batteries, these are the solutions that you see as making it sustainable. What about the other aspects of the development of the boat? We're talking about the materials, like the hull materials. What about paint and other solutions on board? I mean, what's your view, or what are you doing on that front?
So, as I mentioned, what we're trying to do is, replacing all the propulsion system, and by doing so, we moved from the 27% of a thermal engine, the efficiency of a thermal engine, to about 98% of the efficiency that we have in our boat now, of course, before the transmission, which is another area of improvement for the future. We put the boat together in 8-9 months. It was a bit like a birth. And was a hell of a process. And of course, we had to take some shortcut because we had to launch the championship. So, as I mentioned before, we are far from being, flawless and having the ideal solution. We have some constraint related to the racing environment. We have to be light. Our boat is 1,200 kilograms, and we have been trying some linen fiber solution. So we tried, we were not happy about the solution for many reasons. One of these is, of course, the weight, 50% more. And of course, if we would try only with the bow, with the last bit on the front of the boat. And I mean, we were not happy about the quality of the solution, about the weight, and so on. This doesn't mean that we will stick to carbon fiber forever. We know that, of course, this is a compromise and the best solution now in racing. I also hear, being new of the marine industry, that carbon fiber is seen as the solution also in yachting quite heavily by big players. But for sure, we have room for improvement in this area, and we'll definitely try to move the competition towards finding better solution in different parts of the boat and outside the boat.
Thank you. In fact, it brings me to a question for the three of you. In terms of engineering and development of technology, obviously foiling has become a big thing. But how do you, from your experience and your own developments, maybe even if you can't talk about them, what do you see the next evolutions in development to make things better? And in a way, given that we've got engineers and younger engineers in the room and down on the quay, what would be your recommendations? What do you foresee as being, if they want to get involved into developing racing boats for the future? what should they work on, and where do you see the next evolutions taking place for the three of you, whether you're sailing or powerboating?
Who goes first?
Well, these occasions are very, very important for young guys, student to, merge studying with real experience, and particularly in this case with really high-level front-edge projects. So I think this kind of solution, this kind of occasions are fantastic for them, and for us as a yard, because we can look and find energies, ideas, and people actually involved with passion and with preparation in these occasions.
So these university students, they bring ideas, new ideas that then you can turn into reality.
And energy and passion, which is fundamental in our work.
Thank you. It's good to hear about the students, and it's all about the people. Umberto?
Yeah, so for me, what's gonna bring foil to a wider range of crafts is the advances in the controls. Like the more advanced is your say autopilot for adjusting your height and improving the safety aspect as well of foiling, the more it's going to be used. So I see this as one of the drivers, as well as the advances that are being made in developing the sections, the shapes. So if you look 10 years ago, we are nowhere near where we are now. So I guess the trend is gonna keep we are going to keep this trend, and in a few years, I think we will see many more applications of foils to other crafts. Regarding the students, I think it's great to have these sort of challenges, because sometimes when you have to find say a simple solution is often the one that works best. So when you say you have a budget to respect and you have a strict deadline where you need to present your project, then you are forced to find, say, a simple and cost-effective solution. And I think this is a good driver for smart innovations.
Thank you.
Well, on my side, I have to say this is an amazing time to be an engineer, because, I mean, we are pretty far away from the ideal solution. There is so much going on, depending also on the weight of the vessel, or anyway the vehicle. We know that there will be, in the next 10 years, a big revolution in the battery areas with hydrogen, graphene, salt battery. So there is so much to do. So for sure, this is an area. Another area where, I mean, coming from the field that I was working before, I think there is a massive room for improvement in the digital twin. So in the modeling of the behavior of the boat, and the combination of fluid dynamics simulation and structural simulation. So this is something that, of course, in areas like Formula One on the road is very advanced, and I guess this will make a big change in the definition of the future vessel. And talking about future vessel, last point is the design. You know, Tesla taught us that we need to look at cars in a completely different way, and they pushed, you know, all the classic car manufacturer to a design that was never conceived before. And this is coming because of the challenges that are related to the new technologies, the high voltage technology and so on. I strongly believe in foils for a matter of efficiency. I also realize the foils, as Umberto was saying before, they have a limit in terms of maximum speed. And so whatever, either through the foil and maybe moving the foil away after a certain speed, or through other solution. For sure, we need to move our competition from the race to sustainability, which now really is too much of a vague word, to the race to efficiency, which, by the way, is the parameter that all the engineers are educated around.
Thank you. Great. Any questions from the audience, which can be technical or not so technical? Is there a... There's a microphone coming to you. So we have a question here and then a question there. It's fine. We're good on time, so don't hesitate to ask questions.
Thank you. Hi. A question for Roddy, mainly in terms of his kind of application of technology background. How do you overcome, or how do you suggest people overcome the price barrier to innovation? Because if we're trying to push these projects in terms of commercialization.
Thank you for the question. Of course, very relevant. I realize from my budget how much it costs to do to build the beauty that we have on the water now. And for sure, in all the transition and industrial revolution, there is always a cost to pay. I think we kind of optimize it, at least in terms of development costs, because what I've done is importing the state-of-the-art of the supercar and hypercar technologies into our race boat. So in this way, the development cost was more about integration and marinization. This is, I think, another way to approach this efficiency, which is also a cost efficiency. Because what I keep telling to my team, we cannot talk only about sustainability and that's it. If we are sustainable, but then financially we are not sustainable, that's the worst message and the worst example that we can bring to society as a sport.
Luca, maybe you have some comments to make on that pricing question of technology, given what you do as a yard.
I think Roddy did explain very well how the pleasure market, boat pleasure market, is compared to other important and larger markets. So we are touching with hands the cost of this project. You know, about any area of the project is starting from scratch. So engineering, materials, construction. But for sure, we're looking forward. You know, just let's remember how a computer would cost years ago, or our telephone would cost years ago. Obviously, the scale is not going to be the same, but the trend, we hope, is going to be, you know, that.
There was a second question. Of course, it's on the other side, so you have to do a bit of a walk around.
My name is Gernot Neubeck from the Heiterenpals company, Austria. What are you thinking about new technologies that are replacing the classical propeller? For example, the Void linear jet or similar products.
Roddy, power.
Power. So actually, again, thank you for this question, because in my list that I mentioned in terms of the gap in the industry, all the transmission and propeller is a massive area of improvement, not only for the efficiency, but also for the noise. Again, this is the influence for dealing and hanging out with Carlos Duarte. The impact of noise pollution on the marine life is much bigger than we can think of. And actually, during this human experiment called COVID, during that phase when there was less traffic and in many areas of this world, we saw how the marine life was flourishing much more, and we saw species that were not used to be in certain areas just because of that. So for sure, that's a massive, and actually going back to Carlos Duarte, he told me that the propeller is the only example in mobility that is not copied or inspired by nature. So there's no animal that is actually using a propeller to move forward. I mean, at least we haven't discovered it yet. So again, this is an area of great interest for me. I know that there are already startups and small companies working on developing more efficient propellers and capable to reduce the noise. So there is already some movement starting up. In terms of jets or other solutions that are immersed, I don't have an answer, but I know the problem, which is finding the right balance between the drag that you introduce by having a big body into the water and the efficiency that you get from the design and layout standpoint and the efficiency of the jet propulsion type. So interesting area. I'm not ruling it out at all, but there is still some room, for improvement and some development to be done.
Thank you. Any last question? Yes, at the back.
Hi, my name is Jarkko Jäämisen, and one question is regarding the propulsion. And do you think the foils are going to be the universal solution depending of different scale of boats and yachts and ships? And then the other one was that I think a Dynafoil from ABB is a new propulsion type, and that gives about 84% open for the efficiency. And that kind of things, how well you are studying these things.
I need to apologize, but if you could repeat the first part of the question, the first question.
Okay, so my first question is that do you think the foils are universal answer for boating and shipping, not because there's a quite big scale effect in there?
Well, I completely agree. I mean, if we talk about vessels up to maybe 20 meters, 15, 20 meters, foil can be a solution. But again, we are talking in a range between 0 and 50 knots. So, and also the foil comes with a lot of complications. So for racing, for sure, I mean, we have seen the positive effect of the foils, but we also know how much the foils needs to be taken care of, maintained. So it's not like a structural part that you can just leave and use without any maintenance. So it's quite of a complex tool, and so I guess again there is an element of the weight and dimension of the vessel, but for what we have seen, for sure, the foils are a very efficient solution for the speeds that we are interested into.
Thank you. In fact, the question can also be applied for the sailing side. I mean, when we see Team Alicia going around the world, I mean, all these new foiling IMOCAs, and we'll talk about, well, IMOCA is going to be on stage next. We know that it's quite tricky because once you break your foils, then you're a bit stuck. So what's the point of view of the engineering side on the sailing boats, Umberto?
Yeah, just to pick on the last questions, I think also we need to differentiate about, because foiling is not only being, say, airborne, but there are many applications of foils where you, for example, can improve the efficiency of your sailing boat by increasing the righting moment. So, and you're still like a displacement boat, and this can be scaled up to very large sailing vessels. And in fact, we have seen a few examples over the past few years of this trend. In terms of, yeah, as you say, of course, one of the main issues for ocean-going sailboats with foils is the amount of debris that it's in the sea. That's the #1 cause of breakages, is hitting unidentified objects in the sea. So I think unless there is a shift in the amount of litter that goes into the sea, this is gonna be an increasing issue with having appendages extending out from your hull over the next few years. So that's a challenge for sure. And then, as well as Roddy was saying, to be efficient, the surface of your foil has to be taken care of, has to be polished, has to be sanded. So, but I think for non-racing applications, you can lose a little bit of. You can accept a compromise about having maybe a rougher surface, but that can last much longer.
Yes, I just want to add, in the parameters that Roddy was saying, obviously, is the weight, is the displacement of the boat, the size of the boat, but also the speed, the target speed you want to reach. For example, in our new project, which will be a pleasure catamaran, using foils, our max speed will be about 40 knots, and the boat won't be flying 100%, will be skimming. So the propulsion can be a traditional propulsion, and the criticism on the foils is not as high as it is at certain level. So it's very much question of putting together the ingredients and choose the target you want to reach.
Thank you. Thank you, gentlemen. So if I were to summarize in 2 words, I would say efficiency and foiling, right? Okay. Thanks, gentlemen. We'll get to the last bit about racing boats, but which is about sustainability as well, with the what is being developed on the IMOCA class with the support of Marine Shift 360. So that would be our third and last roundtable before the coffee break. If you would like to bring these gentlemen back to their seats with a round of applause, many thanks. So I'm calling to the stage Michel Marie, Marine Shift 360, as a life cycle analysis specialist, and Imogen Dinam Price, trying to say it right, sustainability manager for the IMOCA class. So we'll keep on talking about racing, but racing with sustainability in mind, and what is being done to get to that carbon neutrality objectives. If you'd like to welcome them to the stage, thank you. I will let you introduce yourselves first, and then since it's a joint presentation, you've done a very good work on doing your presentation. So I'll leave you the
Thank you. Hi everybody, I'm Imogen Dinham Price. I'm working with the IMOCA class. I've been with them for the last 4 years. And since then, we've been putting in place our sustainability strategy to take us through onwards to 2030.
Good morning. My name is Michel Marie. I'm, well, as the name said, LCS specialist. Marine Shift 360 is a marine dedicated life cycle analysis tool, but we've started to develop 8 years ago. And I'm a consultant for this project, in particular more specialized on the database behind the tool and the user interface. I've been building composite yacht for all my career, more than 35 years. And it's well, a great privilege to be able to draw on my experience to be able to try to change things and to develop this tool to allow us to give us, let's say, a path towards a more sustainable world. So Marine Shift 360 is a life cycle analysis tool. What's life cycle analysis? It's a big word. I mean, in the presentations before and the discussions before, we spoke a lot about sustainability. In fact, what's really important is to be able to quantify our impact to be able to make a change, and it's where LCA comes into play. We looked Usually in LCA, we follow an ISO standard, and we looked at 3 phases. One is the production phase of your component, then the use phase of that component, and at the end of life of that component. Some choices we make when we manufacture something. For example, you might want to use greener fiber, but you're going to have to use more resin for that greener fiber. So overall, your impact might actually be worse than you thought. LCA combine all those aspects to make sure that you make the right choices. Use phase is obviously a very important part on the full life cycle of any yacht. For cars, for example, we start to use a lot of carbon. We do a lot of carbon as well in our yachts. Carbon is more, let's say, impact intensive, but you're going to reuse the weight of the component and then therefore diminish your use phase impact. So those things are taken into account to be able to get an answer. As I said, Marine Chief 360 is specifically developed for the marine industry. It's a simplified LCA. LCA can be very costly, can be very time-consuming. So behind the tool, we have created some database where some choices are made, so you at the end of the day can make a LCA analysis without being an LCA expert. And the vision is to really give that possibility to the marine industry, so collectively we can get some decision and some choices made to get to a better world. Circularity is a very important part of what we do. Some of those discussion we had before, in the high performance world, we use an enormous amount of material. Just to give you an idea, an American Cup yacht, for example, for 1 kg of the composite structure that we saw foiling around, we use about 50 kg of what I call auxiliary materials, which are there to process and mold the component. So it's a huge amount of waste, and that needs to be addressed. At the end of the day, LCA is just a big spreadsheet where we crunch numbers. But what's really important in LCA methodology is to come up with an explanation for your results and come up with some guideline on how to change things. So there is few things we do in the analysis of the result. There is the hotspot analysis. We try to look at a baseline. It's really important to start with what is the state of play now, highlight the hotspot, and then define a path forward. And at the end of the day, one of the big gain with a tool like this is to save money, because if we use less staff, we're going to save money as well. So I'm passing on to Imogen.
So for us at Mocha, we decided to integrate a life cycle assessment into all of our new constructions, because what we considered is that, well, we won't be able to understand what we don't measure, and integrating a life cycle assessment really enabled us to start looking into the hotspots, identifying the areas which we could improve on. So we devised the scope of our study. We decided that the largest pieces on board, the pieces which were going to be the most impacting, needed to be studied during this process. So at the moment we have around about 12 to 13 EMOCAs being built. So we have 12 to 13 simultaneous studies on the go using MarineShift. We've internalized the process, so we've got specific people dedicated to this study. It means that we receive all the information from the boat yards coming through, so that the teams don't have to do it themselves. We've got enough internal structure to be able to do it. It then means that we collect the data, put it through MarineShift, and then we finalize the reports which give us our results. It's allowing us to see the hotspots and the areas which we need to improve on, and start to think about our future rules. It's also allowed us to sort of also span across our stakeholders to really see how to engage them, to educate them as well, because once they know the areas of improvement, they can also, like Michelle said, start to think about cost, think about different methods to improve waste efficiency, for example. These are some of just the initial results which are coming through at the moment out of our studies, and we can see that waste, for example, is a very large factor. And if the construction yards are able to reduce this through designing their hull or their deck, then they'll be able to have a larger cost reduction as well. One team in particular, which went all the way, was 11th Hour Racing, and they went through the whole study, and they've done already their life cycle assessment for their last build. Today, we can see that we're up to 553 tons of CO2 for the whole IMOCA. So everything which is, of course, included from sales all the way through to electronics. For our study, we've just pinpointed the large areas, which are going to be the masts and the booms, as we saw earlier, and of course the hull and the deck and the foils, so that we can really start to anticipate our future rules, as these are going to be the areas which we really need to reduce, as they're coming out as the most impacting. And just for your general knowledge, if you are thinking of doing LCAs in the future, we just thought we'd put in a little bit of a 6-step guide and the timing that we've already spent on our LCAs at the moment. So just a little overview of how long we have spent doing the LCAs. One of the largest areas at the moment is probably the audit part, because we need to collect the data, and sometimes this can be a little bit long with some stakeholders, but most of the time it goes through quite nicely. And of course, at the end, decision making. It's a very precise percentage there, but I think the decision making, of course, can be very variable in that sort of case. So there we go.
Thank you very much. A very good, strong initiative. Quick first question. So you've done it with 11th Hour Racing. Are you imposing it, or do you intend to impose it on all the other participating boats?
Yeah, so it's already in our rules that life cycle assessment is mandatory for all new constructions. So we have 13 new constructions at the moment, so all will be going through an LCA process.
Thank you. Next question from me is about end of life. I mean, in some cases, some of the racing boats are being recycled and used for other purposes. I do have the example of Energy Observer being a pretty good one, how to make use, give a second life to a boat. Do you take that into account in your marine shift calculations, or even in your IMOCA rules? I mean, how do you consider the approach to end of life of this boat?
So in terms of the ISO approach to LCA, the recycling at the end of life is not attributed to the product A, but in terms of, let's say, product B being starting with a recycled boat or a reused boat, then that impact will be 0. So in that sense, that's how it's calculated. In terms of the IMOCA, I mean, Imogen can speak, but IMOCA is probably one of the class where there's the most reused of all boat. And in that sense, it's quite a big sustainability initiative, which has been going on since the start of that class, where you see both competing in multiple editions.
Thank you, Imogen.
Yeah, precisely. Just want to add, most of our boats, they at least they sail for at least up to 20 years, so you can get through several Vendée Globes, and then of course they go on to do other things after their competitive life.
And in terms of findings from your initial analysis, were you surprised? I mean, what was the most surprising results you found? I mean, what are from the conclusions you can draw, did you find some unexpected results in terms of impact? You were talking about some of them, but I mean, to share with everyone, what should be the first area of looking into making improvements?
So firstly, I think some of the areas are just like the America's Cup as well. We're thinking about the molds. The molds are heavily impacting, and we need to have a bigger amount of effort put into the molds. And So that's one area which we really want to focus on for the next set of our rules. And also the foils, because there are different methods of course, designing our foils today, and there is a lot of waste which is produced when we are creating foils. So that will be another area of expertise which we'll need to devote towards that.
I mean, it's clear in the high performance construction we do, the main impact is, well, 50% of the impact is mainly in the plug and the mold. So by having some initiative like the IMOCA rule or the Americascope rule, we can drive in emissions down by setting up those initiatives at rule level. And we could go even further by not allowing a plug, like everybody has to build a direct mold. We could influence towards certain shapes to allow us to build things still the same way with the same high performance materials, but with a different shape to allow us not to have a mold.
Thank you. That was, in fact, my next question in terms of collaboration with the other classes. Talk about the America's Cup, obviously. It's quite high on the agenda. But whatever, I mean, types of, when you look at the number of regattas and the types of sailing events we have at the Yacht Club de Monaco, is that something that you can see is developing? I mean, are you sharing your findings with the developers of these racing boats, whether it's a laser or J70, whatever? Or is that something that you feel it's still in the early stages?
Well, I mean, my day job is construction manager for the British America's Cup team, so we have some collaboration with IMOCA in terms of rule. It's for sure that the, let's say, sailing world and yachting world in general is a very small community. And with tools like Marine Chief 360, we really start touching the global industry with a lot of partners from the commercial world, as well as high-performance yards and equipment manufacturers. So the message is really starting to spread, and the use of RCA tool like MS360 really help to build that community and to have a common message and a common work towards sustainability.
Yeah, I think with us, within the offshore racing in particular, it's allowing us to also start to consider what we're doing with the other classes. So we're slightly different in terms of the other classes like class 40 or the Figaro class, just because we design and we use a lot of carbon fiber and them all with fiberglass. But at the same time, they've seen our methodology to be able to understand what we're doing in terms of LCA and how they would like to integrate similar systems so that they can start identifying their hotspots and going further from there. So it's a different sort of method, but they can see that our sustainability approach is something that they would like to apply as well. So we're quite transparent with that.
Thank you. Any questions from the audience? Okay, one hand here. 1, 2, 3. Okay, so we start from the front.
Hi, good morning. Thanks for the very interesting presentations. I've got a couple of questions, if I may, actually, one for each one of the speakers. The first one is for Michel. Insofar as LCA, if I simplify, is an accounting task to a large extent and involves also making hypotheses about the use life, for instance, of the components, how do you rate the maturity of the whole industry in being able to come up and supply relevant information for this accounting to be done properly? How do you deal with the uncertainties, and how good do you reckon the results are reliable, the results of the LCAs that we're performing until now, in terms of reliability of the answers?
So this is, well, very good question. I mean, there is two aspects to that question. One is obviously the calculation and what assumptions are made within the database behind the calculation. What we offer with MS360 is a database where we know that has been calculated with the same impact assessment method. So it allows you to generate some scenarios and comparative scenarios knowing that you have the same data behind. That's different from trawling out information from the internet, which might not have the same impact assessment method behind the data point. The second aspect of the calculation is obviously what is going to be spitted out at the end of the calculation is very dependent on what you bring inside the tool. And that's where the inventory, which is done by every user, is as crucial as the database behind. In terms of the overall industry, we are only starting to work on those kinds of scientific evaluations. There is a lot of education to do, but the tool is there to be able to help people playing with those scenarios and to make an educated choice. I think from my point of view and from my personal experience, you learn a lot by doing it yourself, more than reading the result and the outcome of other people. And each time I do an LCA, each time I'm surprised with what I see, and it's really important to do it yourself. Yeah.
Thanks. My second question, if I may.
Make it a quick one, please.
Okay. For Imogen, do you foresee LCAs becoming, say, a binding part of a racing setting project? Could it become a rule requirement, not just that you perform an LCA, but actually that your LCA meets certain requirements that?
Yeah, this is something that we are definitely looking into now, especially as we'll be consolidating all of our LCA results, and the idea is to put in place a carbon cap, and to be able to meet that carbon cap, all the new boats which will be constructed will have to undergo an LCA. The idea for us is that it probably will be with the industry as well, because they're the ones who are actually building. Certain businesses are already they've already got constraints in terms of LCA through legislation, and so that'll be a lot easier for us in that sort of sense. But the idea is that yes, it will be integrated within our rules, and for us the most important is to have a comparable tool which will allow us to be able to have much more reliable results for our carbon cap. Yeah.
Thanks a lot.
Thank you. In fact, is how you see KPIs taking environment into account in most and more businesses. There's no reason it shouldn't be the case in the yachting industry as well. Second question was somewhere at the back. Yes?
Hi, I'm Francis from Polytechnique Montreal. So as a student, we used Marine Shift during the development phase of our boat. Where would you suggest using Marine Shift as a tool during while we're designing our boat? Would you put it more towards the beginning or towards the end as we did it during our project? So we use it kind of at the end of our project to see the impact that it has, but would you suggest using it at the beginning or throughout the process?
So, I mean, I would suggest to use it through the entire part of your project. And I would also like to see teams, like the teams involved in this competition, to use the tool to combine it with more mechanical properties experiments. At the moment, the tool and LCA in general look at the impact per kg of material we use, but within the engineering challenge we're forcing, we should go more towards, let's say, material performance as a combination of material with maybe the aim of having more stiffness or more strength, but really combining those two. And the tool could be used at those early stage of design decisions. And then the tool obviously is used during the manufacturing of your part, but also during the use phase here on the race course. And and then the end of life obviously is always important. In the case of this competition, you look at the end of life of your waste during the production phase, but yeah, if, for example, you reuse a boat at the start, you will have a lesser impact. So there is a lot of areas where LCA can be used. It's through the entire life cycle of any project.
Thank you. Yes, there's two questions here. We start with just behind you with Charles and then Umberto. And these will be the last
Quick question.
two questions.
Where does Marine Shift 360 stop in terms of vessel size? Is there a sweet spot? And then after a certain point, does it lose applicability, and why?
I mean, let's say in the general philosophy, we stop at 24 meters. But at the end of the day, it can apply to a cargo ship if you want to. The database is on constant development, and the user asks us to bring new data point all the time. So it's a growing community, and we can definitely expand it over the 24-meter range.
Hi. One question. I have to say I'm not super familiar with the IMOCA rules, but my question was, how do you factor in the structural design of the boat into the life cycle assessment? I'm going to clarify. I mean, if the structural design is pretty pushed, the boat may have a shorter life, may be able to sustain less, let's say, Vendée Globes, for example, as opposed to a boat which is, let's say, more conservatively designed or may have different structural solutions and may be able to, but this is something you do afterwards, or is something you can predict, let's say?
So I think this can be a question for our next set of rules, because at the moment we're making it just mandatory for the LCA to be in place. There is no specific cap in terms of the impact, so there won't be too many repercussions on the structural design. But now that we're going to be putting in place the cap, it's going to have to meet specific criteria as well, so that we know that the boats are going to be able to have that durability, for example, but at the same time having a lower impact. So it's going to be a bit of a game, I guess, at the moment, to see where we're going to be going with our criteria and how far we can go, so that we'll be able to match the technical performance, but also with the environmental impact at the end of the day.
Thank you.
Yes, well, okay. One last question, and you make it short, please.
I am aligned with the previous question. In fact, and we're speaking with Luca also, because if we really want to have an impact on the CO2 impact, let's say, we have to consider the whole life for sure of the product, but also as organizer of the event, I know that Explore, that raced on the IMOCA previously, they made the sort of life cycle analysis, and they understood that the construction was a very little part of the overall life cycle compared to all the traveling of the crew and all that during the year. So did you also consider changing the rules and the evolution of the rules in order to try to have less construction, in order to have less CO2 impact? Because it's true that we need to push innovation to go in the good direction, to help the industry go in the good direction. But also, if you want to have less consumption, it's good to have a boat that can remain at a good level for a longer period of time. So what's your position in this? Because it's a bit tricky things, keeping innovative, but also being a sort of conservative in order of not pushing teams to create new boat every 4 years.
Yeah, that's a great question, actually. And just to go back to the Explore report, it was with Roland Jourdain. In 2010, they did their first ever environmental management report. And it was clear to see that the construction of an IMOCA is about 20% of the overall IMOCA campaign. Our IMOCA campaign that goes on for about 4 years. So yes, the part which is linked to traveling and team effort and everything was a lot higher than, of course, the boat construction. However, this being said, we really need to have an effort towards the boat builds. And we're not a one design class. We encourage development, we encourage innovation. And so there is this consideration today that we're not going to be standardizing certain parts to one design. We've already got the mast, the boom, the keel fin. But we intend to keep and leave this creativity within the class. And so the rules which work for us are the ones which really incentivize the teams to go the extra mile to integrate this creativity. And if we do put in place this carbon cap, it will allow the innovation to continue to thrive, but we know that we won't be going over a certain limit. So we'll have the boats all at a certain limit, and there will still be a lot of innovation. Limiting the amount of constructions is a question that we're asking at the moment. Of course, it is a question which is possibly slightly more social, economic in that sort of sense, but also at the same time, if our class continues to grow and we've got the same quantity of boats, do we have the capacity to be able to meet that as well in terms of the port size, for example, for certain races like the Vendée Globe? So there are questions which we're looking at the moment.
Many thanks to the two of you. I think it was very appealing, interesting, and eye-opening. I invite you to give them a round of applause to start with. And we're going to have a 20-minute break, coffee break, inside, outside. Enjoy the break. We'll be shifting towards more the yachting, boating side with the next two roundtables, which will be about collaboration. So, from basically development, so getting into collaboration, how important it is to collaborate on these developments and to basically work towards adoption, and how we shift from research and development to engagement to adoption with our next two panels. But in the meantime, enjoy the coffee break. Coffee, tea, fruit juice, everything. Ladies and gentlemen, if you would like to kindly return to your seat so we can continue. I know you're enjoying nice conversations and a coffee break, but we want to stay on schedule. So if you could please return to your seat and bring the people from outside back inside. Once again, we're going to restart. So please join us back inside. Take your seats. Well, in fact, for Jeff, Alex, and Charles, maybe you don't need to take your seats, but you can already join me on stage. This way, we'll speed up the restart. If anyone who's inside but can grasp everyone who's outside, and ask them to kindly join us back in. You need one more glass, yes. Can someone at the bar bring another glass to the table, please? We've got only 2 glasses. Ouais, un verre vide, enfin un verre avec de l'eau. Please proceed back in. We're going to start. So the topic of his next roundtable session, we're all about transitioning, of course, towards sustainability. And in order to do so, one of the things that is quite important in the development of all these projects is collaborative work. So the 3 panelists will obviously introduce themselves, explain who they are, what they do, and then we can start a discussion about how important collaboration is when using new technologies, but especially why. So with me, I've got on the stage Jeff Butler, who's the editor of Plug Boats. Plugboats.com has become quite a reference in the electric boating world. Then I've got Alex Bamberg, who's the CEO of Aqua Superpower, very heavily involved in the electrification of ports and bringing superchargers to help with the development of the electric boating side. Ladies and gentlemen, if you could please, if you stay at the back, and if you stay at the back and are not joining us, could you please try and keep silent or go outside? So that at least whoever is listening to what we're saying can do so in peaceful. Thank you. And then the third panelist is Charles Daines, the co-founder of Spark Marine Projects, who will explain to us how things are changing in the way boat projects for commercial purposes are being developed with a different approach nowadays because of the impact of new technologies. So without further ado, I'll leave it to Jeff to pick the mic while I keep the clicker.
Hello, good morning. My name is Jeff Butler. I'm the editor of Plug Boats, which the slogan for it is everything electric boats and boating. I originally got involved in electric boats because I saw the Monaco, at that time, solar boat challenge on YouTube. And I thought, isn't that fantastic? And I couldn't find out very much about electric boats, so I decided to start writing about them so I could research and then write and find out. And as I did that, more and more people were of the same mind and wanted to find out about them, and started to visit the website and visit the website and visit the website. So we're at about 2.8 million views so far. That was about 4 years ago I started it. And so then I've added different elements to it. So there's motor guides, and there's a suppliers directory. There's boats for sale, electric boats, only electric boats for sale, only electric motors for sale. So as I say, everything electric boats and boating. And I also launched the Gustave Trouvé Awards for Excellence in Electric Boats and Boating, an international competition. So the 4th year of that is coming up now. They're colloquially called the Gussie's Electric Boat Awards.
Thank you, Jeff. So basically from your experience from the recent years' developments, one thing we've been talking about is how these projects, or most of these projects, especially on electric boating, is all about collaboration. And the first question I have for the audience to understand is why these complexities require to have collaborative effort. And I know you've got an explanation for that.
I do. I think I have a cartoon also. I am not an engineer at all. I'm a writer. But the more I found out about it, basically with a fossil fuel boat, not to make it overly simplified, but you have a motor, you have liquid fuel, and you have a way to get the liquid fuel into the motor and a source for the liquid fuel. It doesn't matter if the liquid fuel comes from a pump directly into the boat or into a tank and then dropped in by hand. That is how the whole system operates. And if you want to go faster, then you can add more motors. And if you want to go further, then you can add more fuel. Fairly straightforward. Electric boats are more complicated than that. And so everything needs to work in concert. So the motor needs to work in concert with the battery needs to work in concert with the charger, which Alex will speak of. And when we get into hydrogen and solar cells, then we've really got things, as we know even from the original, or the first presentation today, with the fuel cell, the hydrogen foiling boats. The challenge, I think, partly was getting all these things to coordinate. Then when you add regenerating motors that are going to be recharging the battery, that's another element. You might have solar panels, and if you look at something like the energy observer, then the hydrogen is being created, and it's a whole ecosystem that all has to work together. So it's essential that there be collaboration between all of the players. And I brought up a list of just some of the collaborations. So Candela, the foiling boat from Sweden, is now working with Polestar, the electric car company, and Polestar will be providing the batteries for the Candela motors. X-Shore works with Kreisel batteries in Austria, and then last week announced that they were working with Bosch motors to improve the motors on their X-Shore boats. Torqeedo, I have IBM there. What I meant was BMW. They've been working with BMW over the years with the batteries. Aqua Superpower works with Evoy, Vita. I think I've got it correct here. Delphia, Ingenuity, because all these batteries need to work in connection with the charging systems. It's not like a gasoline pump with a handle. There needs to be a handshake, and it's more complicated than that. With the Oceans Lab sailing boat, you have Genevos Hydro, Ocean Volt with the regenerating motor, Maxion solar panels, Energy Observer, mentioned a bit with EODev, Toyota, VPLP, and Solbian. And then I just saw that the gentlemen from ePropulsion are here, and we were talking about a project they've done in China with Far East boats. And so the company had made catamarans only up to 37 feet. They wanted to make one of 42 or 44 feet and have it electrically propelled. And so they had to work totally in collaboration with ePropulsion on every aspect of how to incorporate this with the catamaran, not just the propulsion systems, but the hotel and all aspects of the electric input and output.
Thank you, Jeff. I'll have plenty of questions. I'm sure there'll be plenty, but we'll carry on with the introductions by each of our panelists first, and then we'll get back to this idea of complexities of technology. Alex, if you'd like to introduce yourself.
Yeah, hi there. It's Alex Bamberg, CEO of Aqua Superpower.
Our total focus is deploying robust electrification to the ports and marinas around the world for the commercial segment as well as the leisure, recreational and sports segment. Clearly, it's all about decarbonisation and the road to zero, and where we have to pull in all stakeholders, including government, to make this happen. Next slide. Yeah. As Jeff touched on very simply, was the need to go away from the requirement when you want to go further, you build a bigger diesel tank. When you want to go faster, you put more horsepower and you burn more diesel. That's not the future. We all have to be smarter. We need smarter dynamics in the hull. We need smarter electronics, and we need reliability, safety, and we need a seamless user experience as we transition away from the liquid carbon fuels. On the diagram on the screen, you see a pretty high level version of what happens as a communication as you plug the boat in and access the charge point, and you take a draw of a certain amount of electrons from the grid, and based on the balance of the grid in the country, we always aim to get the greenest supply, of course. But even in the absence of a total green supply, the electric motor is, of course, fundamentally 70% more efficient per kilometre than an internal combustion engine. So we remain, despite various objections in various areas, a super efficient set of propulsion technologies in the boats. Here's a much more simplified thing, and we offer a couple of routes to charging, and it basically comes down to the duty cycle or the user experience of the boat operator. And we do DC, direct current, which means a boat can charge in, say, 20 minutes to 40 minutes to fill the batteries, or you can do a much slower trickle charge overnight, over 2 or 3 days, depending on the application, the strength of the grid, etc. In our experience, no market will grow in the technology segment if you don't have the user experience and meet the needs of the commercial model that is already laid out in front of us. And I can tell you a very, very brief story. I come from a successful background in automotive charging networks. Many years ago, actually 2015, I was invited to Nissan and Renault in Paris, and they said, oh, you know, we've built the Nissan Leaf factory in the UK, it cost us 6 billion euros. We now have 8,000 Nissan Leafs sat in a field. Nobody wants to buy them. I said, okay, the trouble is you haven't put 1 cent into putting a charging network in place. Unlike Tesla, who of course saw the need for the experience and the good, robust network. I said, you came to market and you sort of beat Tesla in an e-mobility product at a mass market price, and this is a key area, but you failed completely on providing a charger infrastructure. So therefore, all your cars remain unsold. And they said, well, we are relied on home charging only. I said, yeah, but you're spending 30,000, 40,000 pounds for a mobility vehicle, and you can only take it to the shops and back. This does not work. We did a deal with Nissan and Renault. We put 290, at the time, cutting-edge DC fast chargers into the UK. Within 18 months, the entire stock of Nissan Leafs had sold. They then asked us to roll 2,000 chargers out into the European networks. We declined because we were focusing on the UK, but they did it nonetheless with another partner. And that, when you look back, was the very point the e-mobility market globally started to take off. And where we are here today in the marine world, we're back in a similar place, but in a different segment, but we've learned a lot. So Aqua's role here is to dominate the predominant areas around the world in premier and premium sites to enable the users to transition to electrification in a seamless way.
Thank you, Alex. I'll get back to you on the key challenges you've had to face to get to that level of being able to implement the infrastructure. So we'll talk about regulations and governments, as you said. And then our third panelist is Charles Dance, and is a co-founder of Spark. And he will explain to us how this technology basically changes the approach when developing new projects.
Okay, hi, I'm Charles Dents, co-founder of Spark Marine Projects. We have one foot in product development, the other foot in business development. So we help people design, build and sell products. That's our starting point, our backgrounds across design, naval architecture, engineering, project supervision, marketing, business development and sales. We put this together. Our focus has been in recent years on tenders, chase boats, touching on what some of the other people talked about this morning on the kind of sailing, racing side. There's a lot to think about in terms of sustainability that goes into even a small boat project. So it's not just one thing. It's not just powertrain. It's not just foiling. It's at least all of those and probably some more, which to me highlights why collaboration is key, because no one person can do all of that.
Thank you. So the first question I have for you is, we understand that there's a need for collaboration. Jeff gave us some examples as well. At which stage in the end, in the development phase of a boat, and we're talking here not so much about prototype or R&D projects, but with the objectives like shipyards do, to, and we can take the example of Candela, for example, to turn them into production boats. At which stage do you identify, and what's the range of partnerships and collaboration that need to be developed? Jeff and Charles, what's your view on that?
I'm going to give this to Charles because I only received the news at the end of the production. You'd be much more involved in what happens before. Personally, I would think the sooner the better, because one thing that we didn't touch on, or I didn't touch on, is absolutely the efficiency of the hull is another important aspect, or if it's going to be a foiling boat, another important aspect. So I would say, having observed many projects, that the earlier the better in terms of when the collaboration and cooperation can start.
I think take it back a step further. The macro statement is it's the only common denominator for a successful project, whatever you're doing, whether it's boating or not, could be whatever business you're in. I'd say it has to be from the beginning, and that probably reflects a collaboration or innovation and touches on leadership. It's a question of mindset, because it's not the same as an existing business model that's executing on a, just improving or optimizing. It's about trying to do something new and bring something on that didn't exist before. So for me, it's mindset, and it's right at the beginning.
I would just add one thing to that, and I would take the example of Candela. I think we're now at the stage where, when Candela first started, there was no need for intense collaboration with a battery. It was, even though it was only a few years ago, it was the early days. And I think we're now at the stage where there are enough battery makers and options for every aspect of an electric boat to get them involved at the beginning, rather than building a prototype and then saying, oh, well, we'll figure it out after.
So what you're saying is that even when it comes to the conception of the vessel, what you explained about combustion engine, easy, you build a boat, you put an engine in, depending on how much fuel you want. But when it comes to using new technologies, it's like, something that we did touch upon earlier in the morning, that the conception should already take that into account, and these partnerships. So bringing all the various components into the mix right from the beginning, even before you actually develop the boat.
Yeah, 100%. You need to collaborate with your potential customer. Who are they? What do they want? What do they need? Even if what you're going to develop doesn't exist yet, you've got to be going towards something that someone wants. Otherwise, I think, as Roddy said earlier, your business won't be sustainable. You can have an amazing product, but if no one wants it, you're dead.
And it's a tricky question. There's a few shipyards in the audience. What's your impression? What's your feeling about how the industry is taking that on board in terms of developing and conceptualizing? Developing boats, yachts. From that perspective, taking into account that collaboration in mind before they start designing the boat in a way. I'm sure that some other designers, naval architects could answer that. But what's your view on that? Your perception of what the industry is doing into that direction?
I think we can always do better. I think that's the thing, which even as the yachting industry, is how to be less bad or more good. From a yard point of view, if I had a yard hat on, there's a discussion that needs to be had, is who shoulders the risk in terms of financial, and also whether the thing works or not, whatever it is you're investing or innovating on.
Okay, there'll be questions coming from the audience afterwards. Alex, could you tell us a bit more about the difficulties of building up your, not so much the business model, but the fact that when you want to push things forward with around the Med, who do you have to collaborate with, and how tricky or difficult or easy it can be?
Yeah, it's a very good question. I mean, one of the key areas where we're focusing on now is more funding is one thing, and the other area is dealing with private landlords or indeed public landlords, and that is some of the biggest time or bottlenecks in deploying chargers. And this is a speed thing. We are the industry, actually the planet, because let's face it, the planet's pretty much on fire. June was the hottest month ever globally on record, and these statistics keep flying in, and we go around talking to local authorities and central government about how long can we keep a charger in one location to ensure that our commercial model works. We need an ROI of X, otherwise we don't get support. If we don't get support, nobody drives sustainable boats. So the key thing here is to encourage governments to understand that there is an alternative. There's not a whole heap of apologies you have to make. We just need to assist in the transition. So to answer your question directly, we want governments and private sector landlords to be more flexible in giving long-term leases to enable people to invest in the technology.
But is it happening?
Not fast enough. It is happening, but it's too slow.
Well, you mentioned earlier there was the business model of Tesla, you know, with their chargers and building the cars. Do you see something similar in a way taking place in the, or is there a need for that in the industry? I mean, if we'll talk about it tomorrow with the hydrogen roundtable. But in terms of implementation of infrastructure, whether it's charging, whether it's hydrogen stations, is that something that's, you're facing it every day? So what's your, you said not fast enough?
Well, yeah, this is an acceleration of consumer adoption as well. And Tesla, of course, came to market with $100,000+ two-seater Lotus-based sports car, and everybody said, what's that? You know, 10 years later, it's the top-selling car in about 9 countries. What's that telling everybody? Why did that happen? There's pressure from environmentalists. There are, in some countries, good advantageous tax issues, and there are some grants. All of these things need to be accelerated to keep up with the damage we're doing to the planet. What we're trying to do is to create an open network, so any boat manufacturer, unlike initially the Tesla charging network, any boat operator owner can charge on the Aqua Superpower network. And this is a key element of the user experience and fast adoption. That's not as easy as it sounds, because there's some very complex software into the interaction between all the technologies and charging BMSs on the boat side, as well as the charging side, and how it reports to the cloud from a safety, secure, payment and maintenance processes, all of which are key to running a reliable network. So we are leading that charge at the moment very much, and we're finding a lot of success in a lot of places, including here at Monaco, down the Riviera, Italy, UK, and we just started off into the US, so it's an exciting space.
So in terms of making it happen faster, and Charles, your experience in the yachting industry would be interesting to hear. this collaboration, this lobbying that needs to be done to make it happen faster, do you see it happening, or is there any incentive beyond the fact that, yes, you will limit your impact when you're driving a sustainable boat? Are there things happening in the industry that are helping push things forward faster?
Is that me,
yeah.
Alex? Incentive can be a broad word. The incentives can be a stick or a carrot. I think from a yachting perspective, there's a lot of external threats that can come from regulation, government, environmental, social, technological, political, legal. So there's a lot of threats. Whether that's making people sit up and take notice, I think it's starting to. But it's going to come from the outside. I think we're too small an industry to be able to develop stuff by ourselves. Again, as Roddy said earlier, we need to take our cues from aviation, automotive, land-based, shipping. I think we're going to get a lot from, and that's going to be, we're going to have to adopt that. So I think, and one of the other things as well is the cost. There's a cost differential between business as usual, the status quo, and who pays. I'm intrigued. You know, yachting is a particular business. There's no commercial utility behind owning and operating a yacht. So I wonder, and it's a question for everyone, how do we bend the psychology of owning a luxury asset to a more sustainable use case or operation profile or build specification?
If I read between the lines, what you're saying is that it's going to be difficult to convince government bodies, authorities, municipalities, whatever, to help drive the, especially when it comes to infrastructure changes or requirements for an industry that is small and deals with luxury products that is not their main concern.
Arguably, yes, and I think we're going to get regulation handed to us.
But not taking part in partnering with authorities to develop them.
It's optimistic to think that yachting can influence to a huge degree marine regulation. It would be great if we could, but I think, you know, commercial probably has more firepower there.
Thank you. Is there already some questions? I've got a couple more, but I'm sure that there is some.
Maybe a question for Alex. What are you guys doing to avoid what I'd call the Betamax versus the VHS situation, whereby my boat, the plug doesn't work on your charger or vice versa? I know Tesla and Volkswagen Audi, I think, have agreed to recently share technologies or cross-platform. Is there sort of a working standard that you guys are working to?
Yeah, in Europe, there is a standard CCS combined charging system, which is the one Aqua Superpower have adopted. A few years ago, there was a Japanese-based protocol called CHAdeMO. That is slowly being dropped, and Aqua Superpower have not adopted that in the marine space. And this is based, of course, on a well-trodden path on safety and performance based around the automotive solutions, which have now many years and many hours of use. So there is a proper standard in Europe. In the US, it's slightly up in the air between the Tesla NACS system and CCS. The reason for that is that the Tesla product over there and its charging infrastructure is much more dominant. And so there's a natural recourse to go down the Tesla route. Either way, the protocols will be the same. It is just a different adapter, which is easily dealt with.
So even before there is a standardization, there's already fights between different types of systems, rather than collaboration.
Yeah, as in any industry, or certainly tech space, there is a standardization protocol within automotive and marine. But as new boat manufacturers, and indeed new charger hardware manufacturers come into the market, they may have a different interpretation of those secure protocols. That is why all of our network is smart. It reports to the Aqua Cloud. We monitor everything, and we can adjust everything via over-the-air updates. So this is what you see on the dock is maybe a metal box, But up in the cloud, there is far more investment going on to make sure there's a seamless exercise.
Thank you. There's a question here.
Yes, a small question for Alex. How difficult or how simple it is to install a charger on a dock? What are your main problems you're encountering with, I would say, any town or harbor master to install your system? That's the first question. Second question is how salt resistant your systems are, and have you already come up with generation 2 or 3 with your chargers? Thank you.
Yeah, first question is, it's a relatively well-tried early stage of connecting a powerful device to the grid. So we have to apply to for a new grid connection to any particular national grid, if you like, and that can be an expensive and slow process depending on the location. So essentially, Aqua own and operate and connect to the grid, and they own that connection. And that can take, for example, in itself, between 2 and 8 months to make that connection. Then we install the charger, depending on whether it's 200 meters away, half a kilometer away, or 5 meters away from indeed these point of connections. So then we look at the hardware, and we're looking for 2 or 3 types of architecture, whether you have lightweight satellites like we do on the Aqua 200 out here for DC charging, where you have a lightweight dispenser unit essentially right by the boat, and the main power cabinet is actually underneath this building. The other is this slower charging, the AC, which is on the E-dock, which at that power level, it's a sort of overnight affair. Yeah. And as regards marinization, we started early. We adopted some automotive chargers, and we found they were not lasting due to certain saltwater locations. So we've progressively made them more robust. So, for example, the new chargers we've just installed here at Monaco have IP67 connectors. The casing is IP65. So these are essentially waterproof units. In fact, the AC chargers will work submerged, excluding the lead, of course. So, yeah.
Okay, thank you. We shouldn't get too technical into these aspects. You can carry on conversations like over lunch. But getting back to collaborations, you did mention, I mean, all of you have mentioned actually automotive, even aviation. How do you see the issues we face in the maritime industry, like marinization, and the collaboration with, when we talk about batteries, for example, different types of chemistries, how is that moving forward to make things progress or being implemented, adapted, and adopted faster in the yachting industry, maritime world, with this collaboration? How do you foresee that kind of collaboration and development? The example of BMW you mentioned before. I mean, I know BMW have come up with a boat now as well. So what's your view on the evolution of these collaborations?
That's for me?
For
okay, yeah,
all of you.
There are 2 or 3 good battery chemistries out there at the moment, and the key one with the baseline of lithium, of course. And as we see the adoption and price variance, these chemistries will be put into a suitable duty cycle within a suitable boat. So, you know, whether you've got a 10-meter boat, a 20-meter boat, what's the duty cycle it's going to do? What's the longevity of the likely whole life cost of this boat? So there's a lot of moving parts here, which is probably a complex one to answer in depth, but happy to take questions outside this forum.
Thank you.
I would say that also, as Charles had said earlier, that the yachting industry is not going to be the driving force behind this. You know, I used the example of Chrysler batteries earlier. They were recently purchased, I think 50%, but a significant amount, by John Deere tractors. I live in Canada, and now Volkswagen is building an $8 billion battery manufacturing plant there. I would say in the last 2 months in all of North America, there are probably 5 massive battery plants going in. So as these come on board, this is going to make it all more accessible for electric boating. But it won't be the electric boats that are driving it. It's always going to be the automotive market.
Okay, thank you.
I think it's also important to play to your strengths. As you say there, we might not have the scale over the industry, but we do potentially have more early adopter wealthy clients And I think that's one of our only ways out of this, is to encourage more people to invest there. And I think it could work both ways. If you can successfully build a product that operates in a hostile marine environment, it could have application on land, which is, as a species, where we spend most of our time. So it's a tough test bench for something to work in the ocean. So I think that could go the other way as well.
Yeah, just quickly to add, I think everybody needs to pay attention again on this subject, in the sense that in my head, I've got 3 serious benchmarks that are commercial, really, but of course they're based on environmental, and that is lots of countries and legislation will hit us in 2025, where there'll be certain banning and legislative emission controls going on globally, and that's going to have a big impact in businesses that build internal combustion engines. And then in 2030, you've got an even more secure and stricter set of legislations going on, where literally probably 60% of the industry, as far as building engines are concerned, that burn liquid carbon fuels will cease to be allowed to sell them. That's not very far away. In 2035, globally, it's banned. So this is, the marine industry needs to step up, and it needs to adopt this electrification in a very expansive and rapid way.
Thank you. A very strong message to conclude this session. Thank you, gentlemen. And if you want to carry on conversing with them, I invite you to do that afterwards. While we invite our next and final session for the morning, please give these gentlemen a round of applause. We do miss ladies, in fact, in most of our panels, unfortunately. This is something where, obviously, the industry can address as well, trying to be more equal when it comes to genders as well. So for our last session, we'll have representatives from various parts of the industry when it comes to building, developing yachts, from the design and naval architecture to the research and development, to the actual construction of big, small, and bigger size yachts. So please welcome to the stage after the photo. So please welcome to the stage Enrico Benco from Permare Group, Hammer Yachts. From Oceanco Lateral Yachting, Adrien Tomaso. Then we've got Jarkko Jamsen from Navia Design. We've got from Ferretti, Mr. Nino Ascone. And last but not least, from San Lorenzo, Luca Santella, who's back to the stage. So with quite a wide panel of speakers and panelists, where the idea is to show how and to discuss at the various stages of boat and product development, how you move from the R&D side, the prototyping of new solutions, into obviously getting them adopted, validated, and knowledge within the industry and by clients as well, and then to the stage of having full adoption by production, for production, and the market. Luca doesn't need to introduce himself. He's been introduced before. We know who he is. And then we should try and follow the order which is on the slide rather than on the table, for each to introduce themselves briefly, and then we'll get to their presentations. Enrico, if you'd like to start.
Hi. Thank you very much. First thing, I need to apologize for Barbara Merio, who had an emergency earlier this morning, so I'm filling in for her. My name is Enrico Benco. I'm co-founder of GS4C, and we've been working since 2019 with Hammer Yachts on the transition from fiberglass to sustainable composites.
Thank you. We'll get back to materials with you a little bit later. Then we've got Adrian.
Yeah, so I'm Adrian Tomaso. I'm working at Lateral Naval Architect. I'm a naval architect, and I'm also leading the R&D department there. So we are an engineering and naval architecture company based in the UK. We work from anything from a blank sheet of paper to a full engineering package. for owners' team, for shipyards, for designers. We do anything between 24 to probably 200 meter plus, where maybe our core focus is more around 60 to 120 meter, just to say, because it might impact what we say later.
Thank you. We will indeed go back to your explanations about adopting and prototyping R&D to adoption. Next, we've got Jarkko, who's, okay. We're moving too fast. Hold on.
Okay, now I have a seat and a mic, thank you. So my name is Jarkko and I'm a naval architect, wooden boat builder and industrial designer. We have a team of about 100 people in Helsinki working different projects. We are a company behind companies. So we do design for about 10 different brands, turnkey solutions for boats and yachts, and we currently have a range of, I think, about 30 projects running between 3 meters to 260 meters, 4 electric, 3 for full foiling things, displacement, step hulls, light displacement hulls, and about 40% of our business is marine related.
Thank you. And then we got hold on.
Okay. Good morning. My name is Nino Ascone. I'm working for Ferretti, and for the Ferretti Group, I'm following the innovation and the research and development. And Ferretti is I know that everybody knows Ferretti is a big group that includes several brands. Our attention to the sustainability and to the innovation is starting from a long time ago. And in this case, we are developing in time different systems, considering that all our brand that is included in Ferretti include different type, different characteristic of the boat, different size of the boat. In this case, we can consider in different brand, different possibility, different capacity, and different solution for each kind of boat that are regarding this kind of brand.
Okay, thank you. We'll get back to you afterwards. I would like to start with the, I would say, from the initial phases of engineering, design, and development, what we call the R&D side and prototyping, with lateral naval architect. And so get back to this presentation with my slide, so that we can let Adrian talk, and then we'll shift to Jarkko afterwards.
Yeah, I think you can go to the next slide. So when I saw the topic of today, I was thinking instantly at this curve, which is the diffusion of innovation. So this curve is showing, the distribution of from innovator to the late majority or the laggers. And on top of it, you've got what we call the technology readiness level, which is a score, basically a scoring system in terms of maturity of technology. Normally, I think in the aviation, they use the TRL up to 9. In lateral, I think we decided to simplify it, and we only go to 6. So you go from blue sky ID to 6, what we can call obsolete, really. So we use this curve a lot, actually, to try to guide our clients through the choices of technology. We tell them, depending on the appetite, we try to just advise where they should go, with all the risk really associated to the different TRL, really looking at that.
So what you're saying is basically, if we look at that, it's like solar use, whether it's on boat and especially on boat, is already quite advanced. It's like mainstream. Whereas for the other solutions, is basically even on batteries, we're not yet into the peak, but it's coming slowly. And when it comes to hydrogen, we're very, very, very early stage.
Yeah, I think we have to put that back into the context of, you know, our core business. So we're talking about 100-meter vessel. Yeah, compressed hydrogen storage for us is in the TRL 3, which is the marine product development. It's not yet into the first user. It might become very soon, but you know, it's still under the marine product development. The certifying, you know, the marine battery, basically, I do see that between TRL 4 and 5 really is, we are in between the first user to be the real common practice. Solar PV, I mean, you know, it's been in the market for quite a long time. There is a lot of development around it, but for the standard solar PV panel, we do see that as a, you know, a common practice really on our product. So yeah, if you just go back one slide before, I'd say, you know, everything is a prototype until you reach the peak of the innovation curve. So you've got all the prototyping up to, you know, the tipping point, and then you will go down into what we call the mainstream, really. Yeah, I just wanted to illustrate one thing, because we are a naval architecture company. So for us is really important to keep a lot of innovation going on in our office. And I just wanted to present that quickly. The way we are presenting innovation to the clients, to the market, is really by trying to promote some case study or some concept out there where we can actually address the problem of impact on the vessels, the risk ahead. So I think, you know, when I look at this curve of innovation, you know, when we are early stage, this is what we try to do as a naval architect, is really try to promote as much as we can new solutions, explain where we see things. So here we've got the example of the concept Aeolus, which is an NXT project from Oceanco. So they've managed to bring a round of many experts in the field. And what we've done is we've using our energy transition platform, which is a platform which is allow you to start to buy a boat today, state at their heart, diesel electric, and go all the way down to 100% methanol vessel without, you know, minimizing the risk and the impact on board.
Thank you. In fact, I have a question already for all of you. Before we get to Jarkko's explanations, you talk about minimizing risk, reducing risk. With the speed of technology evolution, improvements, I mean, new solutions, like, you know, going so fast, and given the type of investment and cost associated with the R&D and implementation into boats, how do you, all of you, and especially in the yard side, anticipate or mitigate that risk to make the, I would say, the products future-proof? Is that something that you take into account in developing the products, and to what extent? If any ER designer, naval architect wants to answer that question, or each of you.
I'll just introduce this thing. Well, research has moved as fast. So if several years ago, aging for composite, for example, was a question mark, now you can go through aging cycles just to make sure that you know what is going to happen with your composite in several years from now and under different conditions. So this is one of the ways you can mitigate the risk of adoption of new materials, for example. And again, you need to break in a market and in an industry that is very, very conservative at production level. So as soon as you show up with a new solution, first question is why? I mean, we've always done it the other way. Why should we change? So this is a slow process. So you need to show, as we said, it's a journey from the first prototype through research, development of new prototypes, more advanced certification processes, and then early adoption on small parts, and then on the production.
We'll go back to certification. Jarkko, you wanted to?
Yeah, I think That's a super nice picture because we are just doing about 100-meter super yacht. And we are in the stage 1, so it's going to be diesel hybrid. And in that process, we wanted to make it as a full methanol or dual fuel. The problem is that, so in the answer for the question is that you have to know suppliers. So basically, we have to know the roadmap of all the diesel manufacturers, who is going to provide us a dual fuel engine that is capable for that. So it's not the technology itself what is hindering, but I know that in the next 7 years, I can't have a dual fuel engine running in my yacht. So for us, logical decision was to go classical diesel electric, about 30 years old technology, 40 years old technology. I think for us it's a super interesting to have a super deep understanding of suppliers, what they are developing, what are the roadmap of those companies, because we are just integrators in the design.
So what you're saying is then there should be a stronger collaboration, right, as well?
Not necessarily collaboration, it can be also opposite forces.
But yeah, more open source in a way. Yes, Ferretti Group.
I totally agree with what they say, because I believe that in this world, I think that it's necessary to work together because it's not possible. What we said before, that there was the big development of the material. Material is necessary to improve the material, to go ahead in the different material in order to decrease the weight. But in any case, for the yacht, and in this kind of industry, especially for the pleasure yacht, it's necessary that all the industry related to all the main item related to the hull, the develop of the material, develop of the propulsion, have to work together. And the certification is not possible to go forward very fast in one direction and don't consider the other. It's a complex system that we have to consider.
But at the same time, it makes it difficult to be future-proof.
Yes, for sure. It's very difficult because at the end you have to work together. You are not working only on the propulsion, but you have to work on the material, you have to work on the process, you have to work on the certification. It's important that all the items have to work together in order to reach the result.
Luca?
Yes, there is a new technology. It's important to work together. The problem is sometimes there are still not the rules. So that's the big problem at level of certification. I'm talking about European level. So it's going to be a long process, and we have to be very patient and work very hard to get to it.
So technology is going faster than anything else, especially regulations. Anyone from the regulators around to have to comment on that? But we keep it in mind. Thanks. Jarkko, you want to, and I'm going to get, which is the next slide, in fact. Yes. So if you want to tell us a bit more about your view on the, you've worked on the projects, I would say, from beginning to the end and delivery and with a lot of technology. What makes it, what convinces yacht owners, what convinces the end clients to actually adopt new solutions and developing products, I mean, R&D?
Let's go in the super yachts. I think there's another slide for the smaller stuff, but that's good. We keep it this. So super yacht owners for sure would like to have a full, clean product for their brand value. It would be massively important to have it. Well, that's easy to say. It's impossible to make a full electric super yacht currently. Absolutely, mathematics doesn't. If somebody says something else, I will try to be physical. Because we have to be understanding the reality of the mathematics as well. There's a marketing and there's a marketing, but then I'm doing things, I'm building things, I'm making them reality. So I have to be really focused, not to be bullshitting people. We do things, and that's why it's super important that we just focus on the numbers, what we can do. But it's good that there's a next step coming there, and we have to know that that's coming. But those guys would be automatically have a totally clean yachts, if that would be possible. So we have to go step by step. The other one, we were in a global launch of the ABB product. We have done something for that, but mostly in the marketing side. And that's the basically trochoidal propeller, so Dynafin, and that has to open for the efficiency about 84%. The normal board is about 64, axle driven maybe 54. So already in here you have a 30% gains. And what it means like let's say in a commercial vessel, cargo ship, you can save maybe 1 year you can save 5 million liters of fuel. That's quite a lot.
But a solution like this, I mean, this is obviously at the moment at like prototype stage, validated, it works, but how's the adoption of it?
No, well, when you can buy it, it's going to be both. No, the problem is not that, it's not here yet. So if that would be available to buy, there would be a client who would be willing to put it on, but it will take some few years. So in 2 years, for sure, there will be a client for this.
Okay, and the other slide where you said talking about the smaller ones.
Yeah, I think that's what you see in the left side. That's a fully autonomous robot that can deliver goods. That's about 10 years old, full automated with the computer vision, and it has delivered about 7 million kilometers of groceries globally. Anyways, that's one part of our work to create that kind of things. And the other thing is the Candela on the other side. So we are the company behind companies. So we are helping them to create these products. And in the legislation, we are now doing the commercial version of this. And then we have to talk with the DNV how that can be translated in the reality also. But we have about 30, I would say maybe 50 projects in that kind of thing happening in the same time. So making stuff.
Well, when you see the e-boat rally yesterday, I mean, with all these electric boats and different technologies going, you know, a nice trip to Ventimiglia, I mean, you can see that things are moving forward, but at the same time, when I look at the Candela, the C8 here, I mean, I remember the foiler, the very first was like 2012, like 10 years ago, when the initial prototyping of this kind of technology was put together. And we see that boat coming to market quite, you know, nicely, strongly being adopted. So which means basically there's like 10 years gap between the moment the technology R&D is done and we're not even at full adoption stage if you look at your cycle. Is that something that is getting shorter, or, I mean, let's talk to the shipyards, adoption solutions that you're implementing between the development and putting them into the boats? Is that something that's happening faster? Because as we said earlier, as Alex put it before, it's like the house is on fire, right? So we need to really move faster.
Well, I think, you know, just is it moving faster or not? Maybe a little bit, but not that much. I think I just had on what Jarkko mentioned, the ABB Dynafoil, if you just want to take that as an example. If I look back in my inquiries, probably, you know, 6-7 years ago, there were no podded vessels. They were all twin shaft, easy. The pods, you know, managed to get through by, you know, few users, the pioneer. Some clients really want those products in. It has to go through this process and get the feedback, you know, in terms of, is that really performing in terms of noise and vibration? Is that actually, you know, practical? What is the cost? So it has to go through all of that to actually become the majority. And now, you know, probably 80% of your inquiry on 100 meter plus will be probably with pod vessel. So, you know, the cycle of the pod, for instance, if we take that as an example, is probably, 5-7 years. So hopefully it will speed up, but the superyacht industry is difficult to move fast, I think.
Thank you.
Just an example, we were talking about foils. The first foiling boat, power boat, was out in Lago Maggiore in 1920. And in the 50s and the 60s, we had the Aliscafo, Russia and southern Italy. And then everything was calm. So there must be always something special to wake up our industry, probably. And now the house is burning, so we have to move.
but it's always coming from the expectations in the end from the clients, or the shipyards in a way are more proactive nowadays than they used to be? Because you're saying it's very conservative industry, right? So it takes time. But when you put things forward, when you propose something new, is the adoption rate in a way by the clients faster? To what extent the shipyards are proactive in developing things? I mean, yes, okay, Blue Game are doing things with the America's Cup tender, but we can talk about Ferretti Group, like, I mean, I can get to your slide, in fact, then you can talk about the electric boat. The level of proactivity, does it help convince clients, or does the industry always wait for the clients to express their expectations because they heard that they had to do something? Do you see where I'm getting a tricky question?
Okay. I believe that is important to understand that all the technology that we are adopting is necessary to have a request for sure that is coming from the market. In this case, is necessary to be sure that then is requested and is accepted from the market. What in this case, for this the electrical boat that we did, is something that we try. The approach that we had in this case is to find a way to save the brand, the detail. What is the aim? Our aim is to maintain the soul of the Riva boat, the Eliseo, and transform this boat that have his own soul, that is not to respect, and the brand of in an electrical boat. It's not so simple, this kind of passage. It's not so simple, because to transform a boat, maintaining the boat and the characteristic of the boat that is our target, to maintain the Riva as a boat, is the target that I have in this case. We transform only, and we use this boat in order to maintain the characteristic of the Riva, but transforming, using the technology in full electric boat.
Yeah, but that adoption or that project, was it something that came from actually Riva owners maybe saying, actually I want to have Riva, the same spirit, the soul and everything, but I want it clean electric? Or is it a decision by the group, by the yard to say, well, you know what, we should have the same Riva, but making it zero emission?
No, for sure, must be in any case for both sides. Must be a decision of the group, because I believe that in this case, in this moment, we are to try to develop the technology that is mature to be developed in this case, and at the same time, I believe that a boat like this has a market, because it's necessary to consider that this kind of boat.
But using a technology that you deem already mature enough.
Yes.
Okay. Jaakko, you wanted to add something?
Yeah, I just want to say one thing on that. Maybe some of you know a brand called Axopar, and we have designed those boats. And in that range, they have also the electric version 22 and 25. So you put the electric engine Evoy and put the battery bank. I think the biggest challenge is that how we can make the electric version to be competitive with that gasoline version, because the price difference is massive and the range difference is massive. So there will be a quite big negative impact for the end user. I'm not talking about the environment here, I'm just talking about the end user feeling, driving, range, cost. So in the automotive industry, you have an incentive by governments to push it through. In our field, not. So we are just in a business case kind of thing. And that's why I think to make a brands, at least at design, we have to understand that there has to be a business made. It the companies has to survive that they can make the development. And I think to say that nobody has done anything before the electric things came or foil came on, I think it's not fair. Guys have been developing constantly things. This is one part. It might be the right choice or not. History has tried them a few times before, but let's see how it goes.
Yeah, so cost is a big element to take into account for the adoption. When you compare, you said automotive, okay, you get incentives. I mean, you look at the price of electric cars, even the smallest ones are pretty expensive if you don't get the incentives. So the yachting industry, that cost aspect, having higher costly materials, costly, propulsion drivetrains. I mean, when it comes to materials, yes. And
yes, this is what I wanted to say. I mean, it's kind of a chicken-egg situation where, but for materials, is pretty much something that is related to the shipyard choice and a responsibility about making the production more sustainable. All starts with a vision, and in our case, it started with a vision of full cradle-to-cradle recyclability, which is not just chopping things up and remixing them, is reclaiming raw material at the end of life and from all the composite waste. So we started with a vision, scouting the solutions, scouting the materials, the fibers, mineral fibers that can go back to the furnace and can become a new virgin bobbing of fiber. So it's really fully cradle to cradle. And same with the resin. And then you start with a prototype. And then you start the process of qualifying that concept throughout all these steps that you have to go through. So a first prototype, you build a boat, you verify that you can really reclaim the raw material with the, from the composite. And then we started few European funded projects. So just also contaminating different sectors, like we work with Fiat on the automotive sector, showing that the same material can actually fulfill the needs from different sectors. And then you qualify the fiber with RINA, you get the certification process, you qualify the fiber, and then you start, we are starting now with Amer Yachts 3 years long collaboration and research over the optimization of the lamination process, the lamination stack process and the reclaim. Because of course the other question is, you can have a fully recyclable material, but where do you recycle it? So, and this is the infrastructure issue that has the electrification process is also for the materials. You need to build a value chain that will actually cover also for the recycling process.
Okay, so thanks for the explanation. So what I understand here is you've been very proactive. The shipyard has been very proactive in saying, okay, we're investing into that development. When you do that, what's the response from the market, from the clients? It's like, okay, it's going to cost more. You've done a lot of work to developing. It took obviously many years. Certification is a very long process. But do you see that the response from the market is like, okay, you've done the job, we're going to go for it. We're going to buy it, we're going to spend more, but we will go for your solution because it's a good one. Or in your case, you did that development. Or like in the shipyards, do you say, well, this is what we're thinking about, but until and unless we've got a client who says, okay, I'm going to pay for it, agree to it, we won't develop it ourselves, basically. What's your views, all of you?
I'll just add one thing. There's educating the market is one big thing, and for example, and marketing comes into it. But be careful. But there's so much greenwashing going on that marketing can kind of backfire sometimes.
Yes, very much. In our case, we do believe so much in in looking forward, in looking in new technologies, and we decide ourselves to build the boat. When before I talked about the 50 meters, which will be methanol, transformer, hydrogen, and it will be out next year. We will build ourselves because we are sure that it will be the future in that size of boat, that kind of power. So sometimes it's interaction with the client, sometimes it's the shipyard which has to take strength and do it, and luckily we have the strength to do it.
Thank you.
The question is that you can propose on the market something, but at the end it's not something that costs a lot. But at the end, what could be the advantage for the client? What could be the advantage? Is something that in any case, I believe that in the market you have to propose something that have an advantage with respect to other. It can be advantage about the sustainability because the people is sensible to this to this argument, but it's important to maintain at least minimum performance. You have to maintain the characteristic of the noise, the comfort. You have to do this activity, maintaining something that then have an advantage with respect. We have to go forward, not back to something, because then, in this case, it is very difficult. I remember when I started to work in aerospace, there was only aluminum that is working in aerospace. Aluminum is working, it was the only material that is necessary to use, but not because there was no composite, because it's necessary to certify, it's necessary to validate. And then when they did the 380, the A380, that is a full carbon airplane, the market was ready to get this kind of, the 380 is a big success at the beginning because it's a big, the question is that is necessary for all the technology, all the material to verify that there is a possible to do something more, but because there are some advantage to use this one, and this advantage must be clear from the financial point of view, from the economical point of view, from the sustainability point of view. It's not to show something like that.
In a way, it's like they don't invest into R&D, basically. You have to do your R&D before.
To put on the ground some of the technology, the develop that is sometimes difficult because for this reason, because then.
Jaakko, you were giving the example of Axopar. Can you elaborate a bit further on the cost? I mean, obviously that's a brand that's come quite recently into the market and in a way created its, made its presence. As a combination of technology, of the design, of everything, the cost related is things to do, the adoption of it, using the new technology, even if it's more costly, that works?
Yeah, I think it's when you design a product or be part of that kind of development, everybody has to understand what is giving the final consumer extra value. And if the final consumer doesn't see the extra value, there's no extra value. So basically we have to be really strong on that kind of things. And it's nice that we talk about these topics, but in the same time I fully agree that the development has to be because also the producer gets some kind of benefit from that. Currently the difficulty to sell an electric boat is that you get less performance, it's much more expensive. Design-wise, it's quite easy. I don't see any difference. Only thing, that batteries are massively heavy and big, so it's just a little bit more difficult, but not a problem. I think I jump a little bit curveball in a Tesla, because Tesla has been mentioned today, and for me that's a really interesting product, because basically they made a product that everybody can have a supercar with a good conscience. So basically, if we talk about emission and pollution, that's the two things, because in the cars, only is it 7% of the pollution comes from the tailpipe. Everything is small particles from the brake dust, tire dust, road dust, and that's killing, the small particles are killing people in the cities, not the CO2 emissions. But that's a different topic, I don't want to go there. But there's many ways to skin the cat.
Thank you. In fact, since we're talking about some cars, yes, you'd like to say?
Just one last thing I forgot to mention before. The fiber we're working on, basalt fiber and enriched basalt fiber, are better fibers than fiberglass. So on top of being fully recyclable, you will eventually get a lighter boat.
Thank you. Yes?
Yeah, I just want to add quickly something about the cost. So you've got two different types of clients, right? You've got the pioneer, who's willing to invest in new technology, so that's fine. We don't need to convince them. There is the other part of the market, but I think if for them to make compromise, whether it's on the cost or whether it's on the luxury experience on board, there is no regulation which is going to push them at the moment. It might happen, or it will happen eventually. But I think there is the pressure now is coming from social, I'd say. If you think about it, in 2030 in the UK, you won't be able to buy a brand new petrol or diesel car. So, and 2030 is right, you know, it's tomorrow. So
are they changing that law currently in quite many countries?
Are they? Okay,
yeah, so basically let's first see that does it happen or not.
We'll see what happens or not, but I think, you know, my point is the yacht will probably just become unacceptable. And I was there back in March, and we were all saying that, you know, the yacht will become an asset which, you know, if you want to maintain the value, you need to move on with the new technology. So yes, it might cost more, but I think if you can manage to retain the value at the end on the product, is what we need to pitch really. So yeah, it will cost more, but you will get your money back at some point probably, rather than having a product which sit here and it's got no value anymore.
Okay, thank you. I'm sure there's a few questions from the audience. So if you want to raise your hand, yes, in the middle, please.
Thank you. Thank you very much. I'll just stand up. Hi, my name is Engel de Boer, Lloyd's Register, Director of the yacht segment globally. It's not a question per se, but it's a bit of a reaction to some of the comments being made. But also, I'd like to start...
It comes from classification.
I definitely come from classification, one of the regulators. But I wanted to start off with compliments to the industry. You know, you perhaps don't realize that what we've actually managed to achieve over the last 5 years within this industry, within this particular segment, is more than what the entire maritime industry has achieved over the last sort of 20 years, but particularly in this yacht segment. So I think you should be proud of what we're actually achieving. We don't always necessarily have to refer to the others. We are actually doing really, really well, but there is a lot of work which needs to be done. In terms of the regulations, you know, the regulations at the early stages, I mean, we worked with all of the companies and now sitting on stage and many others who are in the process of developing vessels propelled by alternative fuels. In the beginning, there were no regulations. We had to work together with the industry, which is exactly what you need to do when you're dealing with novel alternative fuels. However, 5 years have passed since the introduction of the first concepts, and now fuels, regulations for hydrogen as fuel or methanol as fuel are widely available. So that is already a clear next step forward. Last but not least, very important, as some of you will know at the moment, the IMO is meeting during the MEPC, the Marine Environmental Protection Committee, the 80th session, whereby they will be firming up their strategy with respect to their sustainability challenges. There will be strengthened goals set towards the future, for sure. Yes, to a certain extent, it might not be applicable to this industry, although yachts have been mentioned as we speak even today during the IMO session, because I just got a message about it. As such, if we don't take this responsibility, regulations will be imposed, in my opinion, in the not too distant future, on top of taking into consideration the fact that, you know, the operating areas will be restricted. Thank you.
Thank you. So what you're saying is that, we were talking about it earlier, is that it's going to be difficult for the industry to actually be leading the pack in a way. It's like it's going to come down from whether it's automotive or shipping, especially regulations. But what you're saying is that we've done a lot and we should carry on pushing to do as much, if not more, to in fact avoid having these regulations imposed on us, but in fact more driving them. Okay, thank you. Any question as an actual question? No? All good? Yes? Is it a question or is it a comment? Quick comment then.
Just talking about the adoption curve, I think we got to acknowledge that yacht, or the larger the vessel, the build cycles, you know, talking about 10 years, that's only 2 build cycles for one pioneer client to validate, design, engineer, build, deliver, for it to be validated, and then someone says, yes, let's do it again. That's 8 to 10 years, just there.
Good point about big yachts, especially indeed. which means that the decisions need to be made now. Like you make a decision now for a product that's going to be out in 5 years, and we'll actually have all the new technologies on board.
Yeah, I think for me it's not that bleak where we are or where we are coming in the last 100 years. The Wright brothers learned to fly about 120 years ago. We went to the moon about 60 years ago. We are making massive advancement in humankind. So I don't really see that kind of bleak future. I think everybody's pushing the envelope really hard. And in the same time, of course, we have to be responsible of doing that further, but in the same time, we are doing a great job. There's a really high morale in the people. They are trying to make a super nice stuff. So I would just give a lot of support of all of the people who are trying to make that step, not that kind of necessary, because currently we are almost like a single religion group that we are saying this is the future, and otherwise you are not part of the game. I would try to take that a little bit down and say that try things, do stuff, find out what are the good solutions, and don't believe this rap, what you have been hearing the whole day. Do something new.
Thank you. Quite some nice concluding words in a way in connection to what's happening downstairs. When you see these teams from around the world developing, being creative, thinking about new ideas, new solutions, and defining what the future of boating, yachting, of course, it's mostly about propulsion, management of energy, trying to be as efficient as possible. But they're showing the way, and I'm sure there's lots of talents in there that will, in fact, join the industry and push the boundaries further. Many thanks, gentlemen, and fortunately no ladies around around this round table. Many thanks for your contribution, and on this note, please give them a round of applause before the picture. And so while they do the traditional picture, there's lunch to follow. There's lots to see down on the quay. There should be a parade today with all the boats in the marina. There's going to be quite a lot of fun also today and tomorrow on the outside the marina and inside the marina. Feel free to, of course, have conversations and network with our speakers and amongst yourselves. We made it a bit lighter than last year, where our day was quite intense, dense, and so too dense in a way. So I hope you appreciated it, these sessions this morning, late morning. And thank you for your contribution, participation, and see you next year. And for those who attend the hydrogen roundtable, specifically on hydrogen, see you tomorrow. Thank you.